Alright, so we're going to work with the Cartesian plane. So let's go over this. We have two axes. This one is the x-axis. This one's the y-axis. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And we plot coordinate points. And that's your x and your y. And in this quadrant, both the x and the y are positive. Over here the x is negative, but the y is positive. They are both negative here. And here the x is positive, but the y is negative. Okay? Alright, so how do you know if you have a linear equation? Okay? You have a linear equation when both the x and the y are raised to the first power. So, for example, this would be examples of linear, and this is nonlinear. So a linear equation is something like this. Y equals 2x plus 1. The y is to the first power, the x is to the first power. Y minus 3x equals 5. 5y equals negative 4, or 9x minus 10y equals 3. All of those are linear, and nonlinear examples would be y equals x squared minus 4. See, x is not raised to the first power. Or maybe x squared plus y squared equals 16. They're both raised to the second power, so it's not linear. Or y equals 2 over x. I don't know if you remember this, but when you have a variable in the denominator, you can rewrite it as 2x to the negative 1. So you see this x is not raised to the first power when it's in the denominator. Or xy equals 3, because the x and the y are being multiplied. So it's not linear. Alright, so how do we find the x-intercept and the y-intercept? So the question is, when does a graph cross the x-axis? So basically you cross the x-axis when y equals 0. So you're going to plug in y equals 0 and then solve for x. And the y-intercept is when x equals 0 and you're going to solve for y. So, for example, 2y equals 3x minus 6. So, you want to solve for the x-intercept. So, you would say y equals 0. So, 2 times 0 equals 3x minus 6. 0 equals 3x at 6. And you get that 3x equals 6 divided by 3, x equals 2. So the x-intercept would be when x equals 2. And the y-intercept, you take the same function, this one, but you're going to plug in x equals 0, right? So you have 2y equals 3 times 0 minus 6. Alright, that goes away because 3 times 0 is 0, so you just have negative 6. We're solving for y, so we're going to divide both sides by 2. Y is equal to negative 3. Alright, so the y-intercept would be y equals negative 3. Alright, the standard form of a linear equation is ax plus by equals c, and an example would be 5x plus 7y equals 3. So this is a line, they're both raised to the first power, and it's in standard form. Sometimes we have special cases. Sometimes we have horizontal lines. And we have vertical lines. And a horizontal line is when y is equal to a constant. And the vertical line is when x is equal to a constant. So, for example, how would you plot y equals 3? Y equals 3 is a constant. That means it's a horizontal line at at 1, 2, 3. There you go. And how would you plot x equals -1? Well, when x is a constant, it's a vertical line at -1. Right? So that's that one. Alright, we talk about slope in a line, and slope can be positive, right? When it's leaning like this, or, so this would be a positive slope, or slope can be negative, right? And how do we find slope? Well, slope is, usually the symbol that we use for slope is m, and we say that it's the rise over the run. Alright, so it's going to be, that's the rise and that's the run right here. So rise, run. Or the change in y over the change in x, or y2 minus y1 over x2 minus x1. So the difference in the two coordinate points. So if we have a line, this point can be x1, y1, and this point can be x2, y2. So you would find the slope by doing y2 minus y1 over x2 minus x1. For a positive slope, so let's say m is 3 over 4. I say rise 3, run 4 to the right, because the slope is positive. And if your slope was negative, right, then I would say rise 3, but run 4 to the left. Okay? So, for example, let's say you have -4 and 2 and 2, -3. And I say plot this line and find a slope. So plot and find slope. Right, so the first thing you do is, in this case, since you have two coordinate points, we have -4, 2, so -1, -2, 3, -4, +2. And then we have 2, -3, so 1, 2. So that's the line. And then we have to find a slope, and we said the slope was the change in y over the change in x, right? So remember, this is the first point and that's the second point. So you're going to do the second, make sure you call this one the second one. So -3, oops, not a comma, but a minus sign, -3 minus 2 over 2 minus a -4. And then you work the numerator. -3 minus 2 is -5. In the denominator, 2 minus a -4 is 2 plus 4. So this becomes a 6. So the slope is -5, 6. And it totally makes sense that it's negative because it's slanted this way. Alright, so you might ask yourself, what about the slope of horizontal lines and vertical lines? Well, the slope of a horizontal line, we're going to say that it's 0. And the slope for a vertical line, we're going to say that it does not exist. Okay? Because you end up with a 0 in the denominator for that one. So we say that that slope doesn't exist. It has no slope. Alright, This is the slope-intercept equation, y equals mx plus b. And with this form, it's really easy to find your slope. Your slope is the coefficient in front of the x, and your y-intercept is that plus component. If it's just mx and there's no plus a number, then the y-intercept is 0. So, for example, if you have y equals negative 3x plus 4, the slope is negative 3, and the y-intercept is 4. Okay. Or if you have something like this, y equals 7x, the slope is 7, and the y-intercept is 0, because there's no